Experimental versus theoretical probability. Okay, there's some significant differences between the two, obviously. Experimental probability is essentially what can happen, versus theoretical probability, this is what should happen. Okay, so experimental probability, what can happen, is when we actually get a six-sided dice and we roll that dice over and over again and collect our results. Theoretically, without rolling a dice, without even looking or picking up a dice, we should be able to calculate what should happen. So let's take a closer look at the theoretical side of a dice roll. We've got our notation here, so probability of rolling a 1, probability of 2, right through to a 6. Now, probability of rolling a 1, there's number 1 on a dice out of 6 outcomes. Number 2, again, and each of those possible outcomes on a dice all has a probability of 1 out of 6. Now that's what should happen. Every 6 times we roll a dice, we should get a 1, a 2, a 3, a 4, a 5, and a 6. Okay, let's look at now what can happen. Say we had a six-sided dice, we rolled that dice, let's say 20 times, and recorded all of the outcomes. Okay, and then we can go and actually calculate the probability based on what has happened. Okay, so I've rolled my dice 20 times and I've collected my data in just a simple little table. So down here, all the different outcomes on the dice, 1 through to 6. Second column, I just tallied up, okay, and wrote as a number how many times each of those numbers come out. So I had 3 times where the number 1 come up, 4 times the number 2, twice for number 3, 6 times the number 4. I didn't actually roll a number 5, and I've got 5 times where I rolled a number 6. So now we're going to start to have a look at what that converts to as a probability. Now, down here, we've got 20 total trials for the experiment, okay? So any probability we have is going to be something out of 20. So this one here is going to be 3 out of 20. This one here, 4 out of 20. Okay, so we've gone and filled out that probability column now, and we can see that there is some obvious differences between these outcomes. What we now want to go and do is we want to go and let's just write a little decimal beside over here. Okay, and we're going to convert this to a decimal too, just so we can compare the probability of rolling that 1 on an experiment versus the probability of rolling a 1 in terms of what should happen theoretically. Okay, so on the theoretical side, we had the same probability for each of these numbers, and that converted to a probability of 0.16. Okay, looking at experimentally, so this is what did happen, is that the probability of rolling a 1 was 0.15, so pretty close to that there. Probability of rolling a 2 came out at 0.2, a little bit higher. Probability of rolling a 3 came out at 0.1, which is a bit lower. A 4.3, nearly twice the chance of it happening theoretically. Poor old 5 didn't even get a look in, it had a probability of 0. And then we look at the probability of rolling a 6 and it came out at 0.25, okay, which is significantly higher than this one here as well. So again, theoretical probability, what should happen, okay, experimental probability, what can happen, and we've just seen that it can be very different to the theoretical side of what should happen.